Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I would like to give a bit of explanation continuing the last 2 weeks regarding the schedule design and also the space requirements. So actually it's a part of the systematic layout planning that basically will be the base for this semester, for this course in this semester. Yeah. And I will review again what is actually the systematic facility layout and what a step that we need to do in order for us to find the best layout or the best alternative. And then last week, we already learned about the product design, which is actually you already should have done, and also the process design. So the basic idea itself is how from the product that we try to create, we understand the step by step of the process that is required. And so we will understand what kind of machinery is needed for our industry. Okay, so not only machinery, but also the tools. And once we are able to do that, we basically should be able also to generate the root seed. And from there, we can actually match it up with the demand and then calculate the required number of the machine. So last week, we should be able to finding out the type of the machine that is used. And this week, we'll focus on to find out the number of the machine that we should have in the industry. And thus, we can have the rough calculation of the space requirement for our facility. Okay, so these three are the basic contents for today's presentation. Okay, so if we review again, I actually already give a glimpse, yeah, regarding the systematic layout planning. So the basic idea in the systematic layout planning is how we actually can generate what we want to make and how we will make it and how much we can make it. And then once we understand the whole process, the machineries, we will find out all of the data requires regarding the flows and also the activities inside the industry. Okay, so for example, in the flow itself, it's actually focusing on the product and how the people move. Let's say the staff, maybe the workers, okay, operators, and we are focusing a lot on the product. However, in the activities, we are focusing also in the department aside of the production department. So for example, let's say if your industry is big enough, then probably sometimes you will have a visitor. Okay, it can be your partner or cooperation partner. It also can be, let's say, a student coming for industrial visit and etc. Okay, so the activity, the flow here will focus on the product, while the activities here are mostly product also covered the other activity aside from the production. So let's say maintenance, let's say for example, the activities as our production, okay, maybe you will need to eat in the cafeteria, and then maybe you will need to go to the toilet. And those from this flow, we actually later on can get the rough idea on how the production department will design and the activity, the list of activity will give you short of the list of the department that should be inside your facility. So aside from the production department, for example, you will need warehouse, maybe you will need the receiving or shipping specific space for that. Maybe you also will need cafeteria or meeting room or administrative rooms and so on and so on. And then we, from those data, the flow one, the activities, we can develop the relationship diagram, whether or not some of this flow, so the flow is fixed, right? So we basically just ensure that the product can move as smooth as possible. However, with the activity, we basically try to find out whether one activity needs our department needs to be put close together with another department, and then from the demand data and etc., then we can find out the space required, what is the the rough space requirements. And if we are talking about the existing facility, then we can check with the space availability, okay, whether it's enough, whether there is actually a spare rooms, or whether, for example, if it's not enough, is it possible to actually expand, and so on and so on. Then from this relationship diagram, we will basically create the so-called space relationship diagram, where we can have the rough, a really rough a design of our facility. And probably after that, then we might also create some layout alternative, then do the evaluation before choosing the best layout. Okay. Now let's return to the third step of the process, the product process and schedule design. So in the product, we develop the product. We try to find out the material and etc. We try to find out the specification of the product that we will produce. While in the process, we break down all of the process and machinery needed. In schedule design, basically, we try to find out how much we actually need to make or to produce in order for us to also understand the capability of the industry. Okay, we need to find out the number of the machine, and we need to find out whether or not we will have a long schedule or continuous type of production, or whether it's intermittent production. In schedule design, the decision of the schedule design basically will impact in these some of these factors, such as the machine selection. Okay, each machine, for example, have the different capacity. Okay, so if you are, let's say, have the same milling machine, one manual, one is CNC, probably CNC have the higher capacity. Okay, so later on from the machine selection, it will basically also affect to the number of the machine, because we already have the demand. And then later you will also need to find out the number of the shift, because we will finding out whether the production should be continuous, considering usually the space availability, yeah, and then the number of the employees. Okay, so aside from the production department, usually we also need to think about the material handling for our facility, the storage equipment, some of the personal requirement, and the building size, and so on and so on. Okay, so actually last week I already explained about how each of the process required will need to also consider the so-called defect or scrap in when we are calculating the number of product we need to make every, let's say, each year or daily. Okay, so once we understand that, we actually can try to find the actual in the understand each machine scrap data. We basically can try to find the exactly how much we need to produce. Okay, so I will skip this. Okay, so how to do that is usually based on the routing sheet that we create. So in the process design, we actually also create the routing sheet, right? So aside from the OPC and the precedence diagram, in routing sheet, some of this information is later being used to calculate the number of machine needed. Okay, so in making of this calculation, the routing sheet, okay, the input requires is including the number of product expected, okay, so demand, the scrap percentage, the theoretical machine capacity, the processing time, machine efficiency, and also machine reliability. Okay, so in this case, because actually in the schedule design, we also only consider the scrap. However, once we consider on how we will proceed all of this product, we also need to consider about the capacity of the machine, whether or not, okay, to find out the number of the machine is actually needed, and then the machine efficiency and reliability. Okay, so the number of product to be prepared will be the input of the expected number of the product. Okay, like last week. So this is actually already give this example, right? In I think the second meeting regarding or third meeting regarding the routing seed. So in routing seed, we know the operation number, so which is the same with the OPC. But then we will describe the machinery type that we need, the tooling, and then the time needed, including the setup time and operational time per product or per unit being made. Okay, so because we already have this certain data, now we actually can try to calculate the number of theoretical machine in each operation. So for you actually can calculate the number individually for each machine or all together, although it's a bit probably a sort of complicated. So theoretically, we can calculate the machine required by multiplying the standard time per unit to be produced. Okay, let's say each product or each part needs to have 1 minute from when the operator put the material inside the machinery until the machine stop making, and then the let's say material handler or the operator move those to the other part. Okay, so we can call it as a standard time to be produced. The idea of standard time itself, you should be already learned in the ergonomic class, okay? And you basically multiply it by the number of units to be produced. So if let's say what we try to calculate is number of machine per shift, then the number of unit produced needs to be also in the shift. Okay, and then we divide it with machine efficiency. Machine efficiency usually already consider okay, so for example the machine should be able to work 8 hours per shift. Okay, however, during those 8 hours, probably there is a setup time or break time for the operator, where the machine itself actually not in a on operation or operational position. Those it's actually idle, so we are not basically calculating that. So the machine efficiency just explain about those or the actual performance, multiplying by the machine reliability factor. Usually this data is gathered from the maintenance department, and also the whole amount of time available per machine. Okay, so for example, I said before the working hours 8 hours. So if we convert it into the minutes, then we basically have how much? 180 minutes per machine. Okay. How if we have many equipments at the same time? So the basic idea is still the same. Basically, you calculate the standard time with the quantity divided by efficiency and a reliability and available time. However, then you need to calculate it and then sum everything all together so that you get this required number of machine. But however, I actually suggest you to for each of these machine type because we cannot let's say generalize the number of machine. It's better to use the individual. Okay, so how can we calculate the machine efficiency? So basically, you just need to subscribe 100% with the percentage of the actual machinery is being used for production things. Okay, so if there are machine downtime, if there are setup time, if there are like break time, basically you need to subtract that with that. Okay. And sometimes when we also try to calculate the number of machine, we also need to understand the equipment fractions. So for example, during the one whole day, the company decided to have 3 shifts. However, the demand per month is the same. So basically, the number that needs to be produced each shift will be less. Okay. So, and then we also need to think about the setup times. If one machine, one type of machine have a longer setup time, then we will need to have more machine in order to compensate those long setup time. And if we are not talking about the flexibility, it means that once we run the production, there is no additional product or things, or we are not gonna add up some capacity or decreasing the capacity. Okay, so if however, if we try to be as flexible as possible, the customer might require small lot size of different product, but then they want you to deliver it frequently. Well, it means you will need to have extra machine capacity so that you can meet the customer demand. Whereas it's basically creating small batches, however, have frequently. And then we need to check the layout type and the total production maintenance. Now, let's refresh our memory regarding the standard time. Basically, standard time is defined as the time required to produce a product at the workstation with the assumption, with these 3 conditions, not assumptions. So basically, the operator should be qualified, well trained, and the working should be at normal pace, normal speed, and then the operator needs to do the specific task. Okay, the standard time basically will help to the company to actually have a setup or rules for both the company itself, the number of machineries needed, and also how each of the workstation in different lines actually have the same target and the same result or goal. Okay, so if we actually have the previously we are basically trying to find out how much is actually needed per machine, right? We have a certain data of the scrap, okay, and how actually we can calculate the tag art time is actually using what I already mentioned before. So it means that if we already have the demand number and then the available time, we basically will try to find out the actual times axis for us to produce the product. So for in this case, for example, there are 10% time downtime. So the available time is 432 and not 480. However, because there is also a setup times where each machine have only 90% efficiency, the actual time left for us to produce 1000 part is 389 minutes. Okay. So in that sense, we actually can calculate the tag hour time or the planned time by dividing the available time with the number of units. So it means that each unit will require we only have actually 0.389 minutes. Okay, while the if it means each minute the machine should be able to produce 2.5 units. Okay, while in reality, okay, so basically we only have 0.4. Okay, so the machine needed, okay, is the actual time needed per unit divided by the planned time, which is 1 point something. So we need more than one if we want to produce 1,000 products or something like that. So if multiple operations are completed, it may have its own scrap. So we also need to consider that. And the increase in power required will affect the material that goes into the operation where the scrap rate was calculated. So based on those idea, we actually can create this type of table where we try to find out the number of machine. Okay, so for example, this is kind of like an extension of the routing machine. We have number, operation number, machine, theoretical capacity, efficiency, availability, actual capacity, percent rejected, demand estimation, production yield, number of machine, and so on. And or if we have this data, or if we have the other data, so for example, we only have the standard time or the product rate. We also actually can finding out the number of machine based on the actual time availability. So the upper table is based on the number of actual capacity units, while the table below is based on the actual time availability. Okay, then we actually can move to the what if each let's say each machine, yeah, is not being used by to make different product. However, uh, what if we have multi-product? Okay. So basically, if you have multi-product, we just make the MPPC, okay, which is kind of map where you actually already have some sort of OPC, the symbol OPC, and it shows you what product is going from one machinery to another machinery in order. So if there are backtracking, like the product number 12 and 13, where they are backtracked from the machine 6 to machine 4, it's shown also in this MTPC. Okay, so the number here indicates the process sequence. So it means machine 1, product 1 goes to machine 6, and then 9, 10, 11, and 12, and so on and so on. Okay, and from MPPC, if you have different number of multiple products from MPPC, actually you can roughly calculate without basically not yet, yeah, considering the not considering the carrying machine. However, we basically just calculate with like, okay, machine number 1 is being used by product number 6 and 7, so we at least needs 2. However, if you want to be clearer about that, you can actually calculate it using this. If we have different number of product using the same type of machine. Okay. And for example, this machine number 2 is being used by 9 and 10, and then you basically can try to calculate the actual number machine needed based on these two products, or you can just assume that each product or each machine is dedicated in one particular product. Okay. So this is some numerical example where you try to find out how much actually products is required, yeah, based on this. Okay, so for example, we have table 1 where we it shows the time standard in unit per hour, and then let's say that the company actually assume that in an hour there's only 55 minutes of productive time. Okay, so the other 5 minutes is not calculated, so we actually could have the take our time like this by dividing the value 55 with the value in table this, and then we got table 2. Okay, and if we already know the demand, we basically can try to find out how much is actually each machine gonna needs. Okay, so for example, in this case, the demand, the product that needs to be made, are 12,000, and we have basically, because we have 8 hours working, in each hours you only have 55 time, efficient time. So basically just calculate the 112,000 multiply by the the time needed for each unit, and then we can get the machinery unit. Or you actually can just calculate it. So this is based on the available time, or you can calculate it based on the capacity, like in the second example. Okay, so for example, there is the demand for operator or product 2 and 3. Okay, that is in machine 2. Okay, so you know how much it is. And then there is the time and the needed per pieces, where the total time based on the demand will be equal to PITI. And then basically you just divide it with the calculation of C and multiply by E and RI. So number of machine is equal to PITI divided by CI, EI, and RI. Then we got 3.7. Okay. Now, once we understand the number of machine needed, we actually can try to calculate how many operators is needed for this machinery. Okay, so whether or not this operator should be dedicated in one machine, or whether we can use the same operator to operate different machinery, or the different number of machinery, maybe not one, maybe two, or maybe three. Okay, so there is the so-called multiple activity chart or operator machine chart, when it's break down all of the activity inside of this machine, one machine usually. Okay, so for example, in this case, we break it down each 30 seconds or half minutes, where U means unload, L means load, and I and P mean inspect, yeah, and pack, while R is the run. Okay, so let's say that we basically assign one operator to only one machine, and they need 1 minute to unload, and they unload the previous products made in this machine, and then they need another 1 minute to load all this good. And then the operator, once they load it, the operator run the machine, and the operator basically needs to check all of the product before giving it to, let's say, to the other. So as we can see here, if we see once the M1 run, they actually quite high number of idle time for the operator, because their work actually stopped in the inspection and packing. So the production rate will be equal to 0.125, which is 1 per 8 minutes, or one machine per minute, yeah, per 8 minutes. And then we have cycle time of 8 minutes, but operator idle is 5.5, while the machine idle is 0. Then we can try to increase the number of these two machines, by assigning one operator to do two machine, and then we use the same logic. Okay, although not, let's say they do it parallelly but not at the same time. So let's say the operator unload machine 1 while machine 2 is still running. Then they load it, they do the inspect and pack, while the machine 1 run, they actually can T or transfer to machine 2 and then unload the goods and then load again, inspect and pack, and then travel back to machine 1 and waiting until machine 1 finishes running, and then they will continue something like that. As we can see here, with the 8 minutes time, they actually can have 2 pieces, which result in higher protection rate, 0.35 piece per minute, with the same operator cycle, which is 8 minutes, and the idle operation time is actually decreasing from 5.5 till 2. Okay, now, if the companies feel that the operator idle of 2 minutes per shift for 2 machines is too much, they then can do analysis with 3 machineries and 1 operator using actually almost the same logic. So when the operator do the unload, load, inspect and pack, and then transfer, and then doing the same thing uh, until all the machine is being utilized, we can see here that there is a bit different, slightly different, where the production rate is increasing because within 9 minutes, which is increasing, yeah, the cycle time from 8 to 9, they actually can result or produce 3 pieces. Okay, so in this 3 machine 1 operator, we actually can see that the operator doesn't have any idle time. However, the machine do have machine idle time. And then if we already have such analysis, the decision maker can help to find out the best configuration, whether it's 1 machine or 2 machine or 3 machine with 1 operator. You should also try to conduct this to find out whether the current industry that you are choose is actually have high efficiency or utilization or not. Okay, so once we decide the type of the machine in the process design and then decide the number of the machine in the schedule design, we actually can try to find out, and then the number of employee, the machine operator and assembly, we can try to calculate the space required. Okay, the space requirement basically consists of not only production floor or factory floor, but also the office and other related non-manufacturing departments. And aside from the facility location, making the facility planning or finding out the space requirement is really difficult. And it considered as one of the strategy decisions. Okay, so for example, why it's difficult, I will give you explanation. For example, today's demand is 500, and so we make facility planning based on that. Yeah. However, before we decide or finalize it, we also need to consider whether or not there will be an expansion or any additional spare space that is gonna needed if there is a high demand or increased demand or increased trend. Okay, so the space requirement, but in space requirement, basically we will try to find out the workstation specification. Okay, so for each machine and the workers, how much actually their space for equipment, material, and personnel is. And from there, we can expand by creating the layout for the machine based on the type of the layout itself. So for example, whether it's product layout, whether it's process layout, whether it's a cell manufacturing. Once we do that, we basically can find out, yeah, the actual space required for production floor. Then we also need to ensure the department specification. Okay, so what actually department needed in our facility? Let's say there is a marketing department, or maybe some is R&D department, or maybe we need warehousing aside from the work in process warehouse. Okay, and etc. And then we also need to find out the aisle arrangement. Okay, then we can, once we finalize that, later we can visualize it. Okay, how we calculate the space requirement? Basically, once we find out the number of the machine, we actually can try to create the personal space or the personal operator space. And then with the assumption of personal space is set as wide as 1 meter, and the allowance material for incoming and outgoing is set at 20% of the largest material length, where the aisle allowance is set to 20. Then later, actually, we would need to find out the actual material handler in order for us to finding the aisle allowance. Okay, and then we can add the amount of the transport allowance to the total area of the machine. From the books of Tomkins, actually there are several different aisle allowance considering the size of the load of the product. Okay, the aisle wins is also depends on the type of the material handlers needed to deliver or to move this product. Okay, so for the space requirement and production, what you need to do first is making a personal space like this. So you have the machine, you have the 1 meter wide for your operator, with the length for the operator is actually the same with the incoming materials allowance plus machine plus outgoing material. Okay, if necessary, you will also add 1 meter win for your maintenance. If it's not, then actually if your space is actually quite limited, then we actually can ignore the maintenance by assuming that all the maintenance will happen from the operator side. Okay, and how much is the incoming materials length? It's gonna be the maximum length all of the product that is made in this machine plus 20% of it. It's the same with the outgoing material. Okay, once you create something like this, then you can put it here on the table to find out the total area needed for all the machinery in different department that you have. Okay, so if your product is a process in the process layout, actually the production department will only have one, yeah, let's say a really wide department, okay, production. However, if you are adopting the process layout, then probably the manufacturing consists of different departments with the different machines, so you also can try to calculate that. Once you calculate the production floor, you need to calculate also for the production service floor, factory service floor, personal service floor, and also the office. This gonna depends on how many personnel is your current facility is. Yeah. Okay, for non-manufacturing department, some that you need to consider are office, storage or warehousing, and shipping and receiving. Okay, aside from that, we also need a kind of facility, including the restroom, food service, health service, plant service, like the location for the pump, generator, electricity, etc. And in each of these building location, you also need to ensure that there is an emergency exit. So to calculate the total facility size, first you need to have the PP product process and schedule design, and then you also where you can try to finding out the manufacturing department based on the each workstation on each machinery, and you can add the aisle based on the aisle allowance before. So for the transportation, it's gonna be for aisles, and then based on the personnel requirement, you can calculate the non-manufacturing department, service area, meeting, and etc. And then you can just sum it up from the all manufacturing department plus non-manufacturing department as the total facility. Now, is it over? No. So if to ensure the safety for all the staff, we also need to have aisles or material handling requirements as the allowance to ensure that from one department to another department, there is still space, okay? So from there, we actually can try to find out the total facility, and if it's needed, probably the big company also need to calculate the shipping, receiving, dock access, and also the parking lot. For the personal requirement, usually it include parking lot, locker rooms, restroom, food service, drinking fountain, and health service. Okay, so usually people just kind of like have the locker room for their employee and probably some other room like the toilet. It should be within 200 feet from every permanent workstation, and it should be decentralized. Okay, food service should be centralized, usually in the center of all the whole facility, while the head service will depend on the type of the industry that you have. Okay, and sometimes we also need to think about the barrier-free compliance to ensure that disabled person can also have the access to your facility. Now, I will give you actually 2 weeks. Okay. This is after the midterm, no problem. Regarding the root sheet, basically you need to find out your production requirement. Then from there, you actually can try to calculate the number of machines needed. Okay, once you do that, then you can try to calculate the production floor area, production service area, and etc., so that you can find out the actual total area needed. Okay, and you actually can prepare the presentation accordingly. Okay, so today we have learned review again about the systematic facility layout and the step on how doing that by understanding the concept of schedule design and by able to generate the root seed, calculating the number of machine and standard time, so that we can have find out the space requirement for the facility. This is the reference, and thank you so much for today's lecture. Assalamualaikum warahmatullahi wabarakatuh.